Hi, Margie. So the squeeze theorem. Let's start with a simpler example. Let's start with trying to find the limit as x approaches 0 of x sine x using the squeeze theorem. Okay, so what we know about sine x is that it has values between -1 and +1. So we would go up to +1 down to -1 for a minimum, and then all the values in between. And so if I was going to set this up as a squeeze theorem, what I could do is start with what I know about the sine function. And I know that it's always between 1 and -1 for all values of the angle. So now if I want to change that function to x times the sine function, or x times sine x, then I would have to multiply everything in the equation by x also. And so the limit as x sine x approaches 0 has to be the same if I can find a limit for the other two functions. And so if I sub in x equals 0 into negative x, I'm going to get a limit of 0. And if I sub in a limit of limiting value of 0 into x, I'm going to get 0. So that means that since x sine x is in between those two functions, then it also has a limit. I should have written the lim thing first. A limit as x approaches 0 of x sine x equals 0. Okay, so that's a much simpler function than the one that we were working with when we were doing sine x over x. So I'm going to go to another screen and just show you how that one is set up. Okay, what I'm going to do is I'm going to start with the unit circle for trig, and the unit circle gives us the sine value. That's the first value in the bracket here for the point, and then the cosine value of the angles as we move along. And so here we're going to have like sine of 0 is 0 and cos of 0 is 1, and then we have, this is the radian measure pi over 6 angle, and this is radian measure pi over 4, and this is radian measure pi over 3, and then finally we would have pi over 2 for a 90-degree angle. And so this is where it gets a little complicated, and you wouldn't necessarily know how to set this up and what to look for. But one of the things that we can notice is that because our functions are sine x over x, and then the other function that's given to us in the unit circle is cosine of x, that we could look at what's happening at these various angles and kind of compare them to see if we can come up with a relationship. So sine x of x, if I start at 0, is just, well, we can't, that's undefined there, right? And cos of x is just 1 there. And then if I move out to pi over 6, sine x over x is going to be 1/2, and we're going to divide that by the angle, which is pi over 6, and so that's going to leave us with 3 pi over, it's going to leave us with 3 over pi, and that's 3 divided by 3.14, so that's just slightly less than 1. What does it equal? 0.955, okay? So if I keep going with that, then the next value for sine that I have in my chart is root 2 over 2, and I would divide that by the angle, which is pi over 4. And that's going to end up giving me 2 root 2 over pi, and that's equal to 0.90 something, 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 which is also less than 1. I'm going to keep going, and let's do pi over 3. There we go. So for pi over 3, the sine of the angle is root 3 over 2, and we would be dividing by pi over 3, and that ends up giving us 3 root 3 over 2 pi, and that's equal to 0.8274. And then the last one is at pi over 2, and we just have 1, and we're dividing by pi over 2, so that's going to give us 2 over pi, and that has a value of 0.6369. Over in our cos column, we had 1 at 0, and then the next one at pi over 6 is 0.866. And then the next one for cosine at pi over 4 is root 2 over 2, which is 0.7071. And then at pi over 3, cosine is 0.5, and at pi over 2, cosine is 0. So the one thing that we notice when we're comparing the values here, if we're looking for some kind of pattern or some kind of trick that we can use, sine over x is always greater than cos over x, and all of those are lower than 1, right? All of those values. And so if we look at what that looks like, we could write sine over x in the middle. The maximum value is 1, and then it has to be greater than or equal to, cosine of x. So, sorry, I got interrupted there, so I'm just coming back to this. So all we need to do, obviously the limit as x approaches 0, is just going to be 1, and the limit as cos of x approaches, as x approaches 0, of cos x is also 1, because at 0 degrees cosine is at its maximum. And so therefore, we can prove that sine x over x is the limit of sine x over x as x approaches 0 has to equal 1 also, because it's in between those values for all 0 to 2, pi over 2. That one is pretty tricky. He might ask you to do like a proof like this, like on a quiz or something. I'm not sure. I think he probably is more likely to give it to you on an assignment. I've seen it on an assignment before, so if you do get it, just get in touch and I'll help you get started on it, okay?